Now, this class we will study what is the angular momentum as well as the torque. The last class we have studied what is the moment of inertia of the particle as well as the moment of inertia of the bodies. Okay, and the radius of gyrations that we have studied. The moment of inertia is the inertia of the bodies is coefficient of inertia of the body in a angular momentum is called as, or angular motion is called as the moment of inertia. That is I will call it as. And as well as the radius of gyration K also, that we have definition that we have studied in the last class. Now just I will give the definition on what is angular momentum as well as torque. Then we will study if possible what is the perpendicular axis theorem. So angular momentum is a momentum of the particle is called as angular momentum. What is momentum? The momentum of the particle is mv is called as momentum of the particles. If a particle is moving in a circular with a radius r, then moment of momentum is nothing but mv. What is v? V is the velocity of the particle, linear. Hence we can write, this can be written as m r omega into r. So this is momentum of a particle, and this is given by m r square omega is called as the angular momentum. Hence the m r square is nothing but I omega. I is called as moment of inertia of particles. That is I omega is called as angular momentum. That is momentum is called as angular momentum. Hence the angular momentum of the particle can be written as L is equal to I omega. This is called as what is the angular momentums. The unit for this is moment of inertia can be given as, that is the unit is kg meter square per second is called as the unit of angular momentums. The another definitions called as torque. The torque of the particles or torque of the body can be defined as the rate of change of angular momentum is called as torque. Suppose we have a body, or let us consider a particle, say torque. It is called as tau. Torque is nothing but tau. That tau can be defined as, tau is nothing but force into distance of the particle from the axis of rotations. What is force? Force is mass into acceleration into r. What is the acceleration? Acceleration is nothing but r alpha, mass m r alpha into r. This is called as m r square into alpha is called as tau. Tau is nothing but torque. This m r square is nothing but I is called as the moment of inertia of the particle which is tau, or mathematically we can call it as torque is the product of moment of inertia and the acceleration in the angular acceleration. Alpha is called as angular acceleration, is nothing but torque. And this can also be defined as the torque is rate of angular momentum is called as the torque. This torque is also defined as dl by dt. L is called as angular momentum. So dl by dt is also called as torque. What is L? L is angular momentum, can be given as d. L is I omega, is nothing but L into dt's. This is what is called as I, or this can also be written as I into d omega by dt is called as torque. Hence, this is nothing but I, torque is nothing but I into alpha. D omega by dt is nothing but alpha. Rate of angular velocity is the rate of change of angular velocity is nothing but the acceleration. Hence, this is called as the acceleration alpha. I alpha is called as torque. That is, torque is the product of moment of inertia and the angular acceleration of the particles. And the unit for this is again kg meter square per second square is the SI unit of this torque. These are the two definitions of the angular momentum as well as torque. If you know these basic things, moment of inertia, radius of gyrations, angular momentum, torque, then we study one by one. Consider particles or a body, any shape or size of the body, the angular momentum of the body or the moment of inertia of the body can be calculated one by one. Okay, let us consider the next is called as the perpendicular axis theorems. We calculate first two theorems. One is perpendicular axis theorem, the next one is called as the parallel axis theorem, one by one. Okay, that I will give in the next.